I'm here with Professor Frank Close, who's Professor of Physics in Oxford, and he wrote The Infinity Puzzle, which is about the search for the Higgs. So Frank, maybe I could ask you the most fundamental of questions. What is the Higgs and why should we be looking for it?
Well, the two big questions that we've had is why is there something in the universe at all? The Big Bang created matter and antimatter, and we all know from Star Trek that when matter and antimatter meet, they annihilate each other. So why is there anything left? And we don't know the answer to that.
Okay.
The other big question was, given that there is something left, why isn't it just a hodgepodge of debris rushing around at the speed of light? Why is there structure? Why are there atoms, molecules enabling you and me to be here? And that we probably now have the beginnings of the answer for. That the idea of Peter Higgs and several others, to be fair, is that there's a field throughout the universe, like a magnetic field. We're not aware of the Earth's magnetic field, but a special instrument, like a compass, will point to the North Pole, so you can reveal its presence. Likewise, we're not aware of the Higgs field, but with special instruments like the Large Hadron Collider, we've been able to make its presence manifest. And the idea is that particles, the fundamental particles like the electron, which you find in the outer reaches of atoms, and the quarks, the seeds of the atomic nucleus, as they move through this medium, gain inertia, mass. And that's what gives structure. So the fact that there is structure, we now believe, is because there is this all-pervading field. And that was an idea that has been around for 48 years, and as of a couple of weeks ago, we now believe that experiment shows that idea is right.
So finding the Higgs was the experiment to prove the theory?
Yes. There were at least 6 people who had the insight that it was possible mathematically to write the equations that would do this, but it was only Higgs among them that pointed out that there was an implication of these equations which could be used to test the idea, namely that there should be a massive particle called the Higgs boson, and that it would only live for a very brief moment, and its decays, the pattern of what it decayed into, would be able to show whether these ideas are what nature does or whether it's just clever mathematics.
Something that we wrote down?
Yes.
Okay. And were you at the announcement on July 3rd?
No, but I was with Peter Higgs in a summer school the week beforehand.
And was there any sense that there was something about to happen?
Oh, there was definitely a sense that something was about to happen, but exactly what? Nobody knew, not even Peter Higgs.
Close.
That's right. I mean, the thing is that there was a lot of speculation in the media, which was speculation. And it's a bit like, if I tell you a rumour and you tell somebody else a rumour and it comes back again, I think, oh, there must be something to it. So as a metaphor for the way we do physics, that we do experiments over and over and over again, we're trying to find a signal and separate it from the noise. And the rumours was a metaphor. There were so many rumours going around. Could any of them be real signal, or was it all rumour? It was all rumour. But in the last few days, Peter Higgs had a message from CERN to say, you'll be very welcome to come, and you might be disappointed if you don't. We had got some clues that there was something because the leader of one of the experiments had said about a week beforehand, we can't tell you anything that we're going to say, but I'm pretty sure we'll be able to make a statement one way or the other. Now, in science, you can't prove a negative, so that was a pretty strong steer that they were going to say something positive.